Good morning, class. We're looking at elementary statistics practice test number 2, module 2, covering chapters 4 and 5. Here's chapter 4, probability. And as always, we have a pledge. In short, we are not getting help from anywhere which is unauthorized. And of course, we could use formula sheet, tables, and a graphing calculator. So having said that, let's get started. Chapter 4, probability definition. A simple event is a sample spaces. So let's look at the following definitions. Let's get started. A simple event is an outcome or an event that cannot be further broken down into simpler components. A sample space is the set of all possible outcomes or simple events of a probability experiment. If two events are mutually exclusive, or also known as disjoint, the probability that both will occur is 0. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, disjoint events do not overlap. Probability of A and B, there are 3 different ways of writing them, and we use intersection notation in set theory, is 0. They all mean the same thing. Depending on the text, they may use one notation versus the other one. The probability of an event is always between 0 and 1. P of A, probability of event A, is N of A over N of S. N of S is the number representing the sample space, N of A for the number representing the event of interest, is the probability of event A. And this probability is always between 0 and 1 exclusively. Can it be 0? Yes. Can it be 1? Yes. It can't be negative. It can't be larger than 1. The sum of probabilities of all final outcomes of an experiment is always 1. The sum of the probabilities of all the outcomes in the sample space is 1. Summation of P sub I is 1. All right. Let's look at this experiment as an example. Rolling a die, a regular die has 6 sides. And the numbers are 1 through 6. Sample space. The common die has 6 faces. We usually call the faces 1 through 6. So that's it. That's a sample space, 6 outcomes. A simple event. Any individual number, such as 1 or 5, or you name it, is a simple event. A compound event, any event having more than one outcome, such as odd numbers. For example, we have 1, 3, and 5 as odd numbers. Answer the following. The number of combination of n items selected n at a time. So let's see what that is. Let's discuss the concept. What is the counting method in probability? The counting method is a mathematical technique used in combinatorics and probability to count the number of possible outcomes in a situation, especially when listing them all would be inefficient or impossible. The fundamental counting principle. If one event can occur in m ways and another one in n ways, both together can occur in m by n ways. For example, we have 4 shirt colors and 3 pants. Therefore, 4 times 3, and there is a possibility of having 12 outfits. Sample space in essence. Permutation, order matters. It is an arrangement of objects in a specific order. So the number of permutation, when I discuss this concept. Order matters. Examples, the letter arrangement of ABC, ACB, BAC, BCA, CAB, and CBA are all counted separately if order matters as 6 different permutations. When n different items are available and all of them are selected without replacement. Without replacement is the key. Arrangements where order is important, the formula NPR, n factorial over n minus r factorial. Example, how many ways to assign first, second, and third place from 5 runners? So order becomes important. Combination. Order doesn't matter. Combination is a grouping of objects. Order doesn't matter. Formula NCR, n factorial, or r factorial times n minus r factorial. Example, choosing 3 cards from a deck of 5. And also n factorial is n times n minus 1, n minus 2, all the way to number 1. That's the idea behind it, n factorial. All right, so let's look at this case. N factorial over r factorial, n minus r factorial, or NPR divided by r factorial. Remember, this is NPR, this portion. So we have n items and r happen to be n in this question as well. So n factorial over n factorial times n minus n factorial. This remains, this becomes 0 factorial. 0 factorial is 1. And these two cancel each other, we get just 1. So, combination of any number, if n and r are identical or the same, is equal to 1. So C5, 5, C7, 7, for example. The number of permutation of an item selected 0 at a time. We go with this. We plug in. Okay, that's the meaning of it. This is n minus 0, simply n factorial, and they cancel each other. We get 1. So, the number of combination of n choosing n is 1. The number of permutation from n choosing 0 is also. A pizza parlor offers 10 different toppings. How many 4-topping pizzas, different toppings, of course, are possible? Order is not important. It's a combination. So we're going to use this formula. 10 CR, 10 factorial over 4 factorial times 10 minus 4 factorial. Of course, you can put it into a calculator, but in any event, you can simplify it and come up with the answer. By the way, one way to simplify that, this is 6, so you can write this as 10 times 9 times 8 times 7 times 6 factorial. So you can drop that, okay? You can write this as 4 times 3 times 2 times 1. Okay, 4 and 2 cancel 8. 3 cancels 9, gives us 3. And we get 10 times 3 times 7, 210. Very straightforward. How many 6-letter words can be made from the 26 letters of the alphabet if no letter can be used more than once in the code word? So obviously, order is important. it makes it a permutation. We have n is 26, and we're going to choose R6. And this is 20 factorial, or simply 26 times 25, 24, 23, 22, 21. You come up with the answer. 165,765,600 permutations. Suppose a bakery has a selection of 20 different cupcakes, 10 donuts, 15 muffins. If you are selecting a tasty treat, how many different choices of sweets can you choose? This is an extra example, so I want to look at 45. Why is that? Because we have to choose from either a cupcake or donut or muffin, notice the or, we have 20 plus 10 plus 15 or 45 treats to choose. We're going to choose one of it. How many different choices of sweets? A taste, and that's the key. If you're to select one of each tasty treat, how many different orders can you choose from? Now, this is interesting. So we want to distinguish between the two. We had one choice. Now we have one from each category, 3,000. Why is that? The fundamental counting principle. We can choose treats from a selection of cupcakes, donuts, muffins. And notice the and. So we have 20 choices here, 10 choices here, 15 choices here. The product is 3,000. And that's what gives us a larger number. So we want to be very careful with that. So it's pretty straightforward, everybody. Again, fundamental counting principle. A quiz consists of three true-false questions. How many possible answer keys are there? Write out the sample space and diagram. N of S, that N represents the number, S represents the sample space, is the number of outcomes per stage being raised to the power of number of stages. So N of S is 2 cubed. Each stage has 2 outcomes. How many stages? There are 3 questions. That's the number of stages. 8. So the first stage, true or false, done. The second stage, each one is true or false. So if we just stop there, we have T, 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 F, F, T, F, F. 4 outcomes, 2 squared. We add one more question. The third stage is question number 3. So T, T, T at the top, F, F, F at the bottom. Okay, so you write all of them. So for example, T, 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 F, and the rest of them. Okay, so how many outcomes? 8. The sample space for tossing 5 coins consists of how many outcomes? Write out the sample space. Again, this is the case, which makes it 2 to the power of 5. There are 2 outcomes. There are 5 coins, 32 outcomes. 3 diagram for 5 coins. So we start and we say H and T, heads, tails. So look at the first one, this one. Then the second one, as you can see, just like the previous one, but instead of H and T, in the previous one, we had T and F, true and false. And here's the third one. So if you look at those 3, this is identical to the previous page. Well, of course, again, as I mentioned, true, false. Now, this is the 4th one, and this is the 5th one, 2 to the power of 5. And so what would be the sample space? The very starting point would be H, 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 H. There are five of them. The second one, H, 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 T. And then I go to the last one, T, 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 T. You have to write out all of them. Stage 1, 2, 3, 4, 5. That means coin 1, 2, 3, 4, 5. And those are the sample space as mentioned. So pretty straightforward. A random sample of 100 people was asked if they were for or against the tax increase on rich people. Of 60 males, 45 were in favor, and of all females, 22 were in favor. Write the contingency table and answer the following question. If one person is selected at random, find the probability that this person favors the tax increase on rich people. So you have to set up a table. This is called a contingency table. We have different outcomes. In this case, the way we set it up, male, and we're going to go with M representing the set males, females with F, and the total. Now, for tax increase, against it, and the total. So we're going to put in the numbers, okay? So a random sample of 100. I hope you see 100 goes in here. That's the total size, okay? So 100 goes in here. Of 60 males, M. So 60 goes here. 60 goes here. 45 in favor for tax. So 45 goes in here. 45 goes in here. Of all females, we don't have the size, the total size for the females. 22 were in favor. So 4 in favor, 22 goes in here. So this is 100. 60. 45 goes here. 22. What about the rest? We can easily figure them out. I hope you see that these two add up to 67 here. These two, 45 plus what? 15. In other words, 60 minus 45. Okay. And when you have those, so let me write those and then I'm going to erase them. So over here, 67. Over here, 15. So now I can come up with this 67 plus what number is 100? 33. So if I have 33 here, what number do I need here? 15, and what number adds up to 33? 18. In other words, 33 minus 15. So I can easily fill them up. I'm going to erase my work. And now we're going to answer the question. This person favors the tax increase, and I always recommend to go with the formula P of T, N of T over N of S. T represents for tax increase, A represents against it. So that means always I like to start with N of S, which is 100, and how many are in favor? 67, and we are done. 45 and 22. This person is a female. Well, N of F over N of S. N of S total is 100. N of F, how many females? 40. And you simplify. This person opposes the tax increase on rich people, given that the person is a female. If this person is a female, she opposes the tax increase. That's another way of putting it. This is called conditional probability. And here's the formula. Probability of A given B is probability of A intersection B over P of B. Probability of B given A is probability of A intersection B over P of A. In other words, given probability called the conditional probability will decrease, will shrink in essence your sample size. So your sample size is originally 100. Now it's no longer there. P of A given B, then P of B will be the denominator. P of B given A, P of A will be the denominator, and the numerator is the intersection. And you can go with N. If you change this to N of A intersection B, and this one to N of B, that works the same way. So just wanted to let you know, if you change this to N, that means the number size, because they both get simplified. That works out the same. So having said that, we want to write this person opposes tax increase. Okay, that means probability of opposing is A given F. So probability of A given F is probability of A intersection F over P of F, or you can go with N. So I'm going to start, as I mentioned, with the denominator. So simply put, how many females? We have 40 in the denominator. Of those, okay, females, how many oppose? 18. So 18 over 40, and you can simplify. That's the idea. This person is a male given that that he favors tax increase. So probability of M given T, which is P of M intersection T over P of T, or N of M intersection T, N of T. N of T, how many are for tax increase? 67. And out of those 67, how many males? 45. Or you can, with this one is 45 over 100, this one is 67 over 100, which becomes the same as this one. Always write the exact answer. And when you write the fraction, it's an exact answer. If you want to go with the decimal, how many decimals? However many they ask you. So you should always put enough decimals that covers everything. You're looking at the same question. This person is a female and favors the tax increase. This is the and statement. P of F intersection T is N of F intersection T over N of S. With the and statement, the total size remains unchanged. So N of S is still 100. So the denominator is 100. And if this group, females, and T, this group, in other words, here's the female group, and here's 4, they have an intersection of how many? 22. So 22 divided by 100, and you rewrite it, and you're done. This person opposes the tax increase on rich people, or is a female, and I want you to distinguish between these two statements. And is the intersection of events, or is the union of events. The formula is as follows. Probability of A or B, or probability of A union B, is probability of A plus probability of B minus probability of A intersection B. Okay, so we want probability of A. This person opposes A, or female, A union F. So it's N of A plus N of F minus N of A intersection F over N of S. In other words, please understand their intersection happened 2 times. In other words, if you look at N of A, okay, it's 33. Okay, add these two and you get 33. N of F, add these two and you get 40. So what happens? 18 is accounted for 2 times. That's why you take it off once. So again, let me show you one more time. So here, the sum of these two gives you this number. Here, The sum of these two gives you this number. And so as you can see, 18 is accounted for 2 times. That's why you take it out once. And you get 55 over 100, 11 over 20, or 0.55. By the way, that's an exact number, so you don't have to worry about it. When the denominator has factors of 2 and 5, it becomes an exact. Now, when the fraction has a factors of 2 and 5 only. All right. Now, are the events females? Let me just erase my work again. This event. And opposes tax increase, this event. On rich people. Independent, explain. Well, independency has a specific definition. Probability of A given B is probability of A intersection B over probability of B. Probability of B given A is probability of A intersection B over P of A. That's the conditional probability. Probability of A intersection B would be the cross product, everybody. I want everybody to pay attention to this. See if I put here 1, 1. So pay attention to this. Probability of A intersection B is calculated as follows. Either P of B times P of A given B or P of A times P of B given A. That's a general statement. If independent events, the occurrence of one event does not change the probability of the other event. This definition is very vague and it's hard to understand, but mathematically it means the following. Probability of A given B is probability of A. Probability of B given A is probability of B. In other words, conditional probability becomes a marginal probability and it has no effect on that. Therefore, probability of A intersection B, if independent, becomes probability of A times probability of B. The probabilities, they get multiplied out. That's all. Okay. So, are the events females? We're going to go back. So this was the definition of independency, dependency, and the relationship as to what's going on. And these events are dependent, okay? Events, females, and opposes tax increase on rich people are dependent because occurrence of one of the events does affect the other event. This is, again, vague, probably hard to understand. What do we mean by that? Let's look at it only mathematically. Probability of A given F is 18 over 40. Please understand, A given F. So look at the F, the total size goes down here. And out of those 40, what is A? 18. Is that equal to P of A? P of A is the total size A 33 over total size 100. Are they equal? No. That is the proof numerically. Okay. That is the proof. And you can look at also probability of F given A. I'm going to leave it for you to check that. That's another way of doing that. Are they mutually exclusive? They are not mutually exclusive because a person can be both female and oppose the tax increase on rich people. More specifically, mathematically, you look at the probability of A intersection F. A and F. Here's the A. Here's the F. They come together with number 18, so 18 over 100. So that's a proof again. It's very important to prove things mathematically with numbers. Okay. Find the probability of getting the outcome of tails and 2 when a coin is tossed and a die is rolled. Well, we discussed independency. Probability of A intersection B is probability of A times probability of B, and the two events are independent. That means P of tails and 2 would be P of tails times P of 2. As you know, this is 1/2. This is 1 out of 6 because there are 6 outcomes here. There are 2 outcomes here. 1 over 12 precisely. Again, notice I don't change that to decimal because this is an exact answer. So that's pretty straightforward, everyone. A classic counting problem is to determine the number of different ways that the letter of personnel can be arranged. Find that number. Permutation rule, distinguishable permutations. When some items are identical to others, the number of different permutations, order counts. When n items are available and all n of them are selected without replacement, but some of the items are identical to others, is found as follows. N sub 1 are alike, n sub 2 are alike, and so forth. So n factorial over n1 factorial times n2 factorial, so on and so forth. So a very straightforward, and we are going to look at this case. To do so, first and foremost, understand that we have how many items and how they work. We have P, how many of them? 1. E, we have 1 and 2. R, only 1. S, only 1. O, the same thing. N, we have 2 of them. E, we have accounted for, and then L is 1. So we go with this formula. The number of letters is 9. N is 9. So because 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 factorial divided by that gives us 90,720. It's a pretty straightforward. I hope everybody's okay with that. A box consists of 14 red and 36 blue markers. If we select different markers randomly, what is the probability that they are all red? With replacement, that's the key. Well, probability of red, just one red, is n of red, which is 14 over n of s, which is the sum of the two numbers. So 7 over 25 or 0.28. And again, that's an exact decimal exact fraction because the bottom has only factor of 5 squared. So how many? 3 of them. So it's the same for each case to the third power. So n of, okay, probability of 3 red is probability of R1 intersection R2 intersection R3 P of R1 times P of R2 times P of R3, and each one is the same 0.28, the probability. So probability of 1 red to the third power, and we get 0.02195. To make sure you write all decimals. Write all decimals. I can't emphasize this enough. Everybody always write all decimals unless they're asking you to round it, and then you do so. Otherwise, always write all decimals. What is the probability that they are all red without replacement? Draw a tree diagram and label each branch. First and foremost, even if they don't say that, if there's only one part, it's always without replacement, everybody. You don't pick up a marker, put it back, and pick another one. This is with replacement, then that means put it back and pick another one. That's not going to happen. That's not normal. So if the question has one part and it doesn't mention with or without, that means without. That's important to understand. If you have 3 red, it's probability of R1 times probability of R2 given R1 times probability of R3 given R1 intersection R2. That's the notation if you want to write that. And it's important to understand the first one was just 14 out of 50. And instead of 7 over 25 or 0.28, I'm going to put 14 over 50, just the way it was given. Remember, it's without replacement. So how many markers do we have total? 50. But the second one, 1 is gone. So first the denominator is 49. Red, there were 14. If 1 has been picked, now only 14 minus 1 is left, 13 over 49. The next stage, 49 goes down to 48 because now we have 48 markers left. And there were 14 reds, 1 was taken 13, and 1 more is taken is 12 now. That's how you write it. You come up with the answer. And this is again an exact answer. You can leave it like that. Now, second method. Probability of all three are red, combination of 14, choose 3 over combination of 50 over 3. Or a better methodology would be combination of 14 over 3. That means choose from 14 reds, all 3, and times combination of from 36, blue, choose 0, over the denominator is the same. Why I'm saying this is better? Because what if they say, okay, we want 2 reds, 1 blue, then this becomes 2, this becomes 1. If you go with this one, you may not recognize this. So this is probably a better way of approaching it this way. Any combination it can be taken care of. Now, so the first stage, red 14 over 50, blue 36 over 50. The first one. The second one, if you look at this branch, red goes, okay, first of all, the denominator for the second stage, all of them are 50 minus 1. And for the third one, 50 minus 2. So 49 here is the denominator, 48. So the denominator is clear. Let's look at the numerator. For red, 1 is gone, so 14 minus 1 becomes 13, but blue, all of them are intact, 36. If we go to blue, all red, 14 are intact, but the blue, 36 becomes 35 for the next stage. When you go over here, for example, here, red is gone, so this becomes 12, blue is 36, and I hope you can figure out the rest easily. It's very straightforward, everybody. If the probability of winning a race is 5 over 12, what is the probability of losing it? Given probability of, let's say, W representing winning is 5 over 12, then complementary event probability of A naught, sometimes they call it A bar or A complement, is 1 minus P of A, so 1 minus that. Okay, so probability of losing, L representing losing, is 1 minus probability of winning, which makes it 7 out of 12. What are odds against winning? Here's the definition. The actual odds against event A, O A complement, because it's against it, is probability of A complement over probability of A. And expressed as form of A to B or AB, and A and B are integers. So odds against winning, that means odds for losing. That means probability of losing over the probability of winning. 7 over 12, 5 over 12 is a complex fraction, is 7 to 5. I'm assuming no one has any problem with elementary, algebra. Just the denominators cancel each other. Okay? If the payoff odds is listed as 6 to 1, 6 to 1, 6 times in essence, how much profit do you make if you bet $10 and you win? The payoff odds against event A. Payoff odds against event A equals net profit times the amount of bet. Divide by amount of bet. So payoff odds is net profit divided by amount of bet. So net profit is the product of these two, cross product. In other words, if I put a 1 here. Cross product. So payoff odds against event A times amount of bet, 6 times 10 is $60. When two different people are randomly selected from those in your class, find the indicated probability assume birthdays occur on the same day of the week with equal frequencies. Probability that two people are born on the same day of the week. Well, no particular day is specified. The first person can be born on any day. Then probability of the second person born on the same day is 1 over 7. And so probability of both person would be the product of the two. This one has no particular day, so it's just 7 over 7 or simply 1 times 1 over 7 is 1 over 7. So to understand this better, take a look at this question. So this one says on the same day, this one probably that two people are both born on, I don't know, Monday, Tuesday. You pick a day, specific day. It doesn't have to be Monday, Friday. Now it's different. I hope you see the difference. Probability of first person born on Monday is 1 over 7. For the second person is also 1 over 7. And therefore the answer is 1 over 49. So this one just on the same day, but this one on some day of the week, a specific day of the week. And that makes a huge difference. How many different auto license plates are possible if the plate has two letters followed by four numbers? So two letters, there is no restriction, 26, 26. Four numbers, 10, 10, 10, 10. So 26 squared times 10 to the power of 4, whatever it might be. Three letters, no repeats, followed by three numbers, repetition allowed. So if that is the case, we have 26, then it goes down to 25, then it goes down to 24. And now the numbers, there is no restriction. There are 10 digits. 26 times 25 times 24 times 10 cubed. Four letters, repetition allowed, followed by two numbers. Well, four letters, 26, all of them. There is no restriction. And then two numbers, one of them is 10, no repeats, the other one must be 9. So 26 to the power of 4 times 10 times 9. Four places. Each character is either a letter or number. We have 26 letters, 10 digits. We have 36 characters. There is a 6 to the power. Again, for a question like this, it's important to show this concept and then whatever the answer might be. In a first grade school class, there are 10 girls and 8 boys. In how many ways can the students finish first, second, and third in a foot race? Assume no ties. And this is again using a TI calculator. I'll go over that in a moment. So order is important. Permutation of n or n, there are a total of 18 kids. And the first, second, and third, we want to pick 3. Or 18 times 17 times 16. Or 18 NPR3 for the 896. So you can use a TI calculator with a factorial, enter the value of n first, then press math, select PRB, select factorial, and enter, and it gives you the answer. Order is important. The girls finish first and second in a geography contents, assume no ties. So obviously, order is important. We are looking at the same permutation. However, n is 10 gears, n is the 10, and r is just first and second, 2. So P 10 to 10 times 9, which is 9. Three boys selected for launch duty. First of all, it's a combination because order is not important. Secondly, boys, so n is 8. And how many of them do we need? 3. Combination of 8. Choose 3. 8 factor over 3 factor times 5 factor. You do the math, you get 56. 6 students be selected for a team. Doesn't matter, hockey team or anything. Okay. And obviously, order is not important. 6 students. How many students? 18. Total of 18 students. How many do we need? So that's n is 18. What about r? 6. So combination of n r, c 18, 6. 18 factorial over 6 factorial times 12 factorial will do the job. 18 NCR 6 gives you this number. And there you have it. Five students be selected, specifically 3 boys and 2 girls. Obviously, order is not important, but 3 boys from 8 boys, 2 girls from 10 girls. So for this group, n is 8. For this group, n is 10. So combination of 8, 3 times combination of 10, 2. And why combination order is not important. We just want 3 and 2. 8 factorial over 3 factorial times 5 factorial times 10 factorial over 2 factorial times 8 factorial. We end up with 25 total. Four gears be selected for a field trip. So obviously order is not important. CNR and N is 10, R is 4. 10 factorial over 4 factorial times 6 factorial. 210 different ways. In another game, a player picks 5 numbers from 1 to 48. If 4 of the 5 numbers match those drawn, the player wins. Second prize. What is the probability of winning this prize? Well, anytime we talk about probability, I like to go with the formula. Probability of winning is n of winning over n of s. And I always want to start with the sample space. How many possible outcomes? So n of s, we want to pick 5 numbers from 48. Order is not important because they didn't say anything about the order. We just want to pick 5 numbers from 1 to 48. So it's combination where n is 48 and r is 5. So n of s is combination, and that's another way of writing it. So for combination class, CNR or n comma r in the parentheses or NCR, they all mean the same thing. Okay, so that's different notations. So if that is the case, 48 factorial over 5 factorial, or 48 minus 5 factorial, that would be n of s. Now, what about the winning? Let me erase my work. Now, n of winning, we want to pick 5 numbers from 1 to 48. If 4 of them is correct, well, 4 comes from 5, 1 comes from the other. That means combination of 5, pick 4, and then 48 minus 5 or 43, pick 1. So N, 4 correct one, 1 incorrect one. Order is not important. The correct one, you have to pick it from 5. And the incorrect one, 48 minus 5 or 43 is incorrect. That's why this is 43. So the product of these two, 5C4 times 43C1 over 48C5, that is a combination, whatever the answer might be. I hope you understand the concept. And the answer is that, and you can simplify it. And if you want to go with decimal, you go many. You always write the fraction as the exact answer. If you want to go with the decimal, you write many, many, many decimals. A poker hand consisting of 5 cards is dealt from a standard deck of 52 cards. Find the probability that the hand contains exactly 2 face cards. Again, we're going to do the same thing. Probability of 2 face cards, F stands for face, is N of 2F over N of S. So let's just write it. It's very straightforward. Now, what is a standard deck of cards? A standard deck contains 52 cards, 4 suits, hearts, diamonds, clubs, and spades, 13 cards per suit, totaling 52 cards overall. Face card would be any king, queen, or jack. So N of S, pick 5 cards from 52. Order is not important. Combination of 52, choose 5, 52 factorial over 5 factorial times 52 minus 5 factorial. So the denominator is very straightforward. 52, pick 5, order is not important, it's a combination. Now, what about the numerator? What is N of 2 face cards? First, understanding what is a face card, it was explained. Then N of 2 face cards and 3 non-face cards, because total of 5. Order is not important. Now, as far as the face cards, we have J for jack, Q for queen, K for king, and we have 4 suits, 4 times 3. There are 12 of them. Okay. The rest of them, 52 minus 12, that means 40 must be non-face. So what is N of 2 face? We want to pick combination from the 12, we want to pick 2. And the rest of them is 40, we want to pick 3. So N of 2 face is 12, combination 2. This is because we need 2, and the rest, this number 3 is 5 minus 2, is from the rest of them 40. And this what matters. This is telling your reader you know exactly what you're doing, and of course, putting it into a calculator and simplification is not that important. It's very straightforward. That would be the final answer. 209 over 833, simplified version. And if you have doubts, write it as a decimal with, I don't know, 10 digits, 12 digits, just to be on the safe side. A factory received a shipment of 16 sprockets, and the vendor who sold the items knows there are 7 sprockets in the shipment that are defective. Before the receiving foreman accepts the delivery, he samples the shipment. And if too many of the sprockets in the sample are defective, he will refuse the shipment. If a sample of 7 sprockets is selected, find the probability that all in the sample are defective. So probability of all defective is N of all defective over N of S. So first and foremost, what is N of S? There are 16, okay, and we want to pick 7. So that is n of s. That's important to understand. That is the denominator. Now, if they're all defective, okay, we're going to choose 7 from 7, and then the rest from, if 7 is defective, 16 minus 7 is 9. And from 9, we're going to choose nothing, 0. Okay, so n of all defect would be C7, 7, C9, 0. By the way, 7, 7, when the n and r are the same, the answer is 1, and 9, 0, this is also 1. But the the reason I like to write this, because if in case you wanted 6 and 1 from here, okay, just for the sake of argument, then this would be 6, this would be 1. You put it into a calculator, and all you have to, this is 1, everybody. This is 1, so is this. So you do the denominator and 1 over the denominator, 11,440. Now, the second method is this. There are 7 spots, and the first one is 7 out of 16. The second one is 6 out of 15, 5 over 14, and so on, and that gives you the same answer. You can approach it this way. What if a sample of 7 spots is selected? Find the probability that none is defective, and of course the denominator is the same thing. So n of non-defective, n of s remains unchanged. But let's go back here. So for this one, C7, 0, okay, C9, 7. I hope you see this will make it easy to write it here. C7, 0, because we don't want any defect, and the rest of them 7 from 9, and this is 1. So it has no bearing. You calculate this one, you calculate this one, 36 over 11,440 becomes 9 over 2860. Here's the second method. 9 out of 16, non-defect, right? 8 over 15, 7 over 14, 6 over 13, and the rest of it gives us the answer that you see here.